If you grew up in the United States, this looks completely normal. Two flat slots, one round hole, a simple up and down switch. But the moment you travel outside the US, everything changes. Different shapes, different plugs, different switches, different rules. So why do American light switches and outlets look like this? Why haven't they changed in decades? And why does the rest of the world use designs that look more advanced? The answer isn't style. It's history, electricity, and safety, locked into the walls. Every outlet and switch design in the world is a direct result of electrical decisions made over 100 years ago. Once those decisions were locked in, everything else had to adapt. Appliance design, wall layouts, safety codes, manufacturing standards. Change the outlet, and you'd have to rebuild the country. The United States was one of the first countries to electrify homes at scale. In the late 1800s and early 1900s, electricity was new. Standards didn't exist. Safety knowledge was limited. Companies raced to bring power into homes as fast as possible. The priority wasn't perfection. It was speed and affordability. That early start shaped everything. This is the most important part. The US standardized on 120 volts for household electricity. Why? Because early light bulbs worked better at lower voltages, less shock risk, safer with early insulation, compatible with fragile filaments. Lower voltage meant thicker wires, higher current, less efficient transmission. But it also meant fewer deadly accidents in a time when safety knowledge was limited. That decision locked in the outlet design. The classic American outlet looks simple, but every part has a job. Two flat vertical slots. These represent hot wire, electricity coming in, neutral wire, electricity returning. The flat shape prevents rotation, ensures stable contact, reduces accidental disconnection. Early round pin designs slipped and sparked. Flat blades solved that problem. The round hole, ground. That third hole wasn't always there. It was added later when engineers realized something terrifying. If a metal appliance failed internally, it could electrify the entire casing. The ground pin redirects dangerous electricity, sends it safely into the earth, prevents electrocution. It's a silent emergency exit for electricity. Look closely. One slot is taller than the other. That's not sloppy manufacturing. It's intentional. It forces the plug to be inserted one correct way. Why? Because certain appliances connect the neutral wire to their internal metal frame. If reversed, switches could stay live. Metal parts could shock you. Fire risk increases. Polarization quietly protects you, even if you never notice it. American light switches look basic compared to European designs, but there's a reason. They control only one wire, the hot wire. When you flip the switch, electricity is interrupted at the source, the circuit is broken safely. Early American wiring favored simplicity, easy repair, low cost. Complex switching systems existed, but they were harder to maintain in wooden houses. Simple switches reduced fire risk. Once electricity became widespread, governments stepped in. The US created strict electrical codes that controlled outlet placement, switch height, wire thickness, grounding requirements. These codes prioritize consistency, predictability, safety over innovation. If every house used different designs, electricians couldn't work safely. Uniformity became a safety feature. Now compare this to Europe, the UK, and other regions. Higher voltage, 220 to 240 VV. Many countries chose higher voltage because electricity arrived later. Insulation improved. Efficiency mattered more. Higher voltage means lower current, thinner wires, more efficient power delivery. But higher voltage also means more dangerous shocks. That's why other countries use thicker pins, deeper sockets, shutters, recessed designs. The outlet shape had to compensate for danger. American outlets look flimsy, but they're matched to their system. Lower voltage allows exposed slots, lighter materials, Simpler contacts. The design looks unsafe compared to Europe, but within the US system, it's balanced. Change the voltage, and the outlet becomes dangerous. Many countries require built-in shutters. The US didn't, at first. Why? Because early homes had fewer outlets, placed them higher, assumed adult supervision. As usage increased, safety codes evolved. That's why modern US outlets now include tamper-resistant shutters, ground fault protection, GFCI, arc fault protection, AFCI. The design evolved without changing the shape. Redesigning outlets isn't just about plugs. It would require replacing every outlet, updating every appliance, retraining every electrician, rewriting safety codes, refitting factories. That cost would be astronomical. So instead, the US improves safety around the design, not by replacing it. You may not notice, but outlets are evolving. Modern versions include USB ports, smart switches, surge protection, sensors, automation. The face stays familiar, but the technology behind it changes. It's evolutionary design, not revolutionary. Familiarity creates trust. People feel safe with designs they grew up with, systems they understand, outlets that feel normal. Changing the look could actually increase mistakes. The brain prefers predictable systems, especially with electricity. Technically, yes. Practically, no. It's safe within its system. The outlet isn't bad design. It's design frozen by history. So the next time you flip a light switch or plug something in, remember, that shape isn't random. It isn't lazy. And it isn't outdated by accident. It's the physical footprint of decisions made a century ago. When electricity was dangerous, houses were wooden, and safety meant simplicity. One outlet, one switch, one country still living with its earliest electrical choices, quietly, safely, every day.